Good evening, students. Am I audible?
Yes, sir.
So we'll get started with the next subtopic, that is a moving coil galvanometer. This is the last topic of this chapter, right? So shall I start?
Yes, sir.
Okay. So when you talk about a moving coil galvanometer, it works on what principle? It works on the principle of torque experienced by a current carrying coil placed in external magnetic field. So torque is equal to NIBA sin theta. But when it comes to a galvanometer, there is a radial magnetic field that is used, due to which always the value of theta is going to be 90, which implies torque is equal to NIBA. So if I say NIBA is equal to K into phi, where phi is going to be what? The deflection. Then I will be equal to K divided by NBA into phi. Right. Now the question is, I'll be able to define two parameters. One is phi divided by I or I divided by phi. I'm right. By rearranging the equation, I can form it. So what is this phi by I called as? So the number of divisions per unit ampere.
Current sensitivity.
It's called current sensitivity. So when they ask you the current sensitivity, you need to calculate phi by I. The reciprocal of current sensitivity is called as figure of merit. You have heard this term, right? You might be having practicals also. Half scale deflection method. Yes or no?
Yes, sir. Yes, sir.
So you have this figure of merit. The next is voltage sensitivity. What is voltage sensitivity? Voltage sensitivity is equal to phi divided by V. So phi divided by, in the place of V, I can write it as I by R. So phi by I is going to give me current sensitivity divided by resistance. Is going to give me the voltage sensitivity. Am I right? That's it. Okay. So having these things in mind, we'll get started with the problems. So tell me how to solve this problem. Okay, I'll take a simpler one. Wait. Okay, I think this itself is simpler. Do it. So there is a rectangular coil of area 5 into 10 power minus 4 meter square, and the number of turns is going to be 60, right? It's pivoted about one of its vertical sides. Okay. The coil is in radial horizontal magnetic field of value 90 Gauss. So 90 into 10 power minus 4 Tesla. What is the torsional constant of the hair springs connected to the coil if the current is 20 milliampere, produces an angular deflection of 18 degrees? Tell me how to solve this. So one thing you need to remember is, don't remember the formula. NIBA is equal to K phi. That's it. Which implies N is how much? 60 into I is 20 into 10 power minus 3 into B is 19.
3 into 10 power minus 9.
I think so. So 90 into 10 power minus 4 into 5 into 10 power minus 4, the whole divided by 18 is going to be the value of K. So 18 into 5, so it goes 300 into 20 into 5 is going to be 100 into 10 power minus 8 minus 11. So this is going to be 3 into 10 power 4 into 10 power minus 11. It should be 3 into 10 power minus 7, no?
Sir,
Yes, sir.
18 degrees, should we take it directly?
Yeah. We
Sir,
will
10
report
power
the
minus
answer.
9, sir.
Minus 9. 1 minute, let me check. So 300 into 10 power minus 7.
Sir, it's 0.20 microns. So another 10 power minus.
Oh, 0.2. Okay, 0.2 means it should be how much? Then it should be 10 power minus 4.
Yes, sir.
12 on that. I'm still getting 10 power minus 8. Where did I go wrong?
Sir,
No, sir.
20
You
into
wrote
10
20,
power
no,
minus
sir.
6,
So
5, sir.
minus 5, sir. 20, 10.
Okay. So 13, then it should be minus 9. Minus 9. Right, divisions per degree. Sorry, Newton meter per degree. Newton meter per degree. Next, a rectangular coil having each turn of length 5 centimeter and breadth 2 centimeter is suspended freely in again radial magnetic field of induction 2.5 into 10 power minus 2 Weber per meter square. Torsional constant of the suspension fiber is 1.5 into 10 power minus 8 Newton meter per radian. Here it is given in radian. The coil deflects through an angle of 0.2 radian when current of 2 microampere is passed through it. Find the number of turns in the coil. Same thing, no? NIBA is equal to K into 5. N is what you need to find. I is how much? 2 into 10 power minus 6. B is how much? 2.5 into 10 power minus 2. A is how much? 5 into 2 into 10 power minus 4 is equal to K is how much? 1.5 into 10 power minus 8 into this is going to be 0.2. So how much will you get? 2 into 2.5 is 5. 5 into 10 is 50. So N into 50 into 10 power minus 8, 12. So 10 power minus 12 is equal to 1.5 into 2 is going to be 3. So it is going to be 0.3 into 10 power minus 8. Or I can write it as 3 into 10 power minus 9. So N will be equal to 3 divided by 50 into 10 power minus 12 divided by, 10 power minus 9 divided by 10 power minus 12. So how much is it going to be? 3 into 10 power 3 divided by 50. So 10 will cancel this 2 times. So 300 divided by 5 is going to be 60. There are 60 turns. Right? There are 60 turns present in this coil. Okay. So do this fast. So they have mentioned find the current sensitivity in units of degree per microampere. Find it in the same way.
Sir,
Hmm.
current sensitivity should be reciprocal.
Sorry, 5 by I wrote figure of merit. Sorry. So this is I by 5. So 5 by I will be equal to 1 by 4 into 10 power minus 6, which is 0.25. This 10 power minus 6 falls under micro only, no? So 0.25 degree per microampere. No, no. I hope you understood. So 0.25 degree per micron, that's correct. See, all are similar kind of problems. So one last, and then we'll go to the conversion of galvanometer to ammeter and voltmeter. So current of 200 microampere deflects the coil of a moving coil galvanometer through 30 degree. What should be the current to cause the rotation through pi by 10 radian? What is the sensitivity of the galvanometer? Do it fast, no?
Sir, in the
Hmm.
previous question, example, we are getting 25, sir. It's in amperes. So microamperes, we should multiply by 10 power 6.
Divide, no?
Okay. Yes, sir.
A current of 200 microampere deflects the coil of a moving coil galvanometer through 30 degree. What should be the current? I2 is equal to how much? For phi2 to be pi by 10. What is the sensitivity of the galvanometer? So what will be the case? I1 by phi1 will be equal to I2 by phi2. Am I right? Because the same galvanometer, the current sensitivity is going to be the same, or figure of merit is going to be the same, which implies I1 by I2 is equal to phi1 by phi2. So phi1 is in terms of 30. So it is pi by 6 divided by pi by 10. Cancel both. It is going to be 10 divided by 6 or pi by 3. So I1 is 200 into 10 power minus 6 ampere into 3 divided by 5 will be equal to the value of I2. So how much will it be? It's going to be 40. So 120 into 10 power minus 6 ampere will be I2, or 120 microampere will be I2. So current sensitivity, when you want, divide 30 with 200 or pi by 6 with 200, based on that, write it in terms of degree per ampere or radian per ampere. Am I clear? So next, the last concept of this chapter is conversion of galvanometer into ammeter and voltmeter of the required values, right? So for a conversion of galvanometer into ammeter, what are we supposed to do? You need to connect a shunt resistance. And what is going to be the value of the shunt resistance that we need to connect? It is going to be Ig divided by I minus Ig into Rg, where Ig is going to be the full scale deflection current and Rg is going to be the resistance of the galvanometer. I is the value of the current that needs to be measured by that ammeter. Right. Next is, for conversion of a galvanometer into voltmeter, what are we supposed to do? You need to take a high resistor and connect it in series with the galvanometer. And what is the value of the series resistance that you need to connect? It will be V divided by Ig minus Rg. Okay, where V is the volt that you want to measure, you want the voltmeter to measure. Ig is the full scale deflection current, and R is going to be the sorry, RG is going to be the resistance of the galvanometer. Clear? So having said this, let's try problems. And if you have any doubt, please get it clarified. Okay. So read this question. A galvanometer with a coil of resistance 12 ohm. Shows a full scale deflection when a current of 2.5 into 10 power minus 3 ampere is passed. How will you convert it into a meter? How will you convert the meter into an ammeter whose range is 0 to 7.5? So I is equal to 7.5. Right. So if you want to convert a galvanometer to an ammeter, what are we supposed to do? You need to connect a shunt resistance whose value is given as Ig into Rg divided by I minus Ig. What is the value of Ig? 2.5 into 10 power minus 3 into Rg is going to be 12 divided by I is going to be 7.5 minus 2.5 into 10 power minus 3. So generally the 7.5 minus 2.5 into 10 power minus 3 is approximated to 7.5. So 2.5 into 10 power minus 3 into 12 divided by, if I approximate it to 7.5, this will go 3 times, this will go 4 times. So 4 into 10 power minus 3 ohm is what we need to connect. So by connecting a resistor of 4 into 10 power minus 3 ohm in parallel to the galvanometer, we'll convert it to a ammeter. So can you guys calculate the series resistance and tell me?
So 3,988.
3988. Correct. So what is the value of series resistance? You will connect V divided by Ig minus Rg. V is how much? 10 by 2.5 into 10 power minus 3 minus Rg is going to be 12. So this 10 power minus 3 goes to the numerator. It becomes 10 power 4 divided by 2.5 minus 12. So 10 power 4 is basically 10,000. So make it as 10 power 5 divided by 25 minus 12. So I can write this as 10 square into 10 cube by 25. So 4 minus 12. So how much is this? 4,000 minus 12, 3988 ohm. So it's going to be 3988 ohm that you need to connect it in series. Next.
Sir,
Determine the net. Sorry,
just a minute. Yes, sir.
determine the net resistance of each meter. So resistance of ammeter is going to be so what is going to be the resistance of the ammeter? Galvanometer and shunt resistance are connected in parallel. So resistance of galvanometer into resistance of shunt divided by Rg plus R shunt. So what is the value of Rg? 12. So 12 into R shunt is going to be 4 into 10 power minus 3 divided by 12 plus 4 into 10 power minus 3. So again, the approximate value, if you take it, how much is it going to be? So 12 plus 4 into 10 power minus 3, if you approximate to 12, 12 and 12 will get cancelled. So 4 into 10 power minus 3 ohm will be the effective resistance of the ammeter. Similarly, what is going to be the resistance of the voltmeter? It will be resistance of galvanometer plus the series resistance. So what is the resistance of galvanometer? 12 plus 3988, that is going to be 4000. Okay. Do this. So after this, I'll do one more problem. After that, we'll move on to the next chapter. So a galvanometer with the scale divided to 100 equal division has a current sensitivity of 10 divisions per milliampere. So 5 by I is equal to 10 by 10 power minus 3. That is going to be 10 power 4. Okay. And voltage sensitivity of so 2 into 10 power 3. Okay, divisions per volt. What adoptions are required to read 5 ampere for full scale and 1 division per volt? What adoptions means? What are the changes you need to do to this galvanometer so that it gets converted to a 5 ampere for full scale? So IG should be 5 ampere.
Sir, we can find R by dividing current
You have to
sensitivity, like current
find out
sensitivity upon what? Yeah.
how much is the value of R?
5 ohms, sir.
5 ohm.
Yeah, resistance of the galvanometer.
Correct. Resistance of the galvanometer comes out to be 5 ohm. Now you want a 5 ampere for full scale. So I will be equal to 5 ampere. Right. How will you find the value of IG?
Hundred into 10, sir.
Why 100 into 10?
It's the total number of divisions. So full scale will be into 10. So 10 divisions. No, sir. It will be 100 divided by 10.
It should be 100 by 10. Right. So 100 divided by, is it not 10 power 4?
Okay, milliampere. So yes, sir. Got it.
Ampere. No, it is 100 divided by 10 power 4. It will be 10 power minus 2, which will be 0.01 ampere. See, those who didn't understand, listen to this carefully. When you pass 1 milliampere of current, the galvanometer gets deflected to 10 readings. So how many such amperes are needed for it to get transferred to 100 degrees? 100 equal divisions is what the question is. So if you are able to pass a current of 0.01 ampere, the galvanometer will go and sit at the 100th division, the pointer of the galvanometer. That is the meaning of full scale deflection current. So this is IG. So you know RG, you know IG. Calculate, no? Tell me. What is the resistance you need to connect? Shunt resistance is equal to IG into RG divided by I minus IG. So IG is 10 power minus 2 into RG is going to be 5 divided by I minus IG. So I over 5 minus 10 power minus 2. So it will be 5 divided by 499. Check it. Because 10 power minus 2, if you take LCM and then do it, 500 minus 1 divided by 100, that will go to the numerator. 10 power minus 2 and 10 power 2 will get cancelled. So you're left out with 5 divided by 499 ohm. So this is what we need to connect to convert it to a ammeter.
Sir, why can't we approximate over here?
Because see, in the previous case, the number was to 3 decimal value, no? That is why we did it. And comparatively, the other number was also slightly bigger, 12.
Okay, sir.
But here, if you approximate, you are going to get something like 0.01 something.
Yes, sir. 0.01, sir.
It approximately be the same only, not a big difference. Similarly, what are we supposed to do to get 1 division per volt?
Sir,
Tell me.
sir, how are you getting RG equal to 5?
RG is 5 because they have given current sensitivity. VSC 5 divided by R into IS is what is 2 into 10 power 3. So 5 by that they have given it as 10 divided by 10 power minus 3.
Yes, sir.
Plug that value here. Other than the R conductivity.
Okay, sir.
Okay. Actually, you'll get 10 by 2. So that is 5. So they are saying they need a voltmeter where for 1 volt, it is going to 1 division. So how many divisions are there for this galvanometer? Guys, listen to my point carefully. They want a voltmeter where for 1 volt, there is a point, the pointer is getting deflected for 1 division. So how many divisions are there for this galvanometer? 100. So what is the voltmeters range they're expecting? V is? Guys, I need an answer. 100 volt. So if you need a 100 volt galvanometer, a 100 volt voltmeter, how will you, or what resistance will you connect here? R will be equal to V divided by Ig minus Rg. So 100 divided by Ig is going to be 5 minus Rg is going to be 5. So it's going to be 20 minus 5. So you need to connect a 15 ohm resistor in series.
Sir, IG is not 5, right?
That's what I was thinking.
Sir, IG is 10 power minus 2.
That's what. It cannot be this small value. Ig. So 10 power minus 2. So you'll have 10,000. Correct? 10,000 minus 5. 9995. Oh. So generally the resistance of voltmeter will be somewhere greater than 5,000. So answer is 9995 ohm. Are you able to understand? See, this is actually a very good problem. Because the data is hidden here. Those who understood, try it again later. Okay. Shall I proceed? So as I told you, one last problem. With that we are done. Make it fast. 2 minutes time. Do it fast. Find resistance of the ammeter and the shunt.
Sir, 2 upon 30.
How much?
2 upon 30.
0.16, no? Which is 2 upon 30? Shunt resistance.
Sir, no. Combined resistance.
Combined is RA into R shunt. RA is 0.8 into R shunt is 0.2 divided by RA plus R shunt, which is 1.
Sir, how is it 4, sir? It's 4.2.
Which one is 4.2?
I dash minus I.
I dash is 5, I is 1. You did I dash minus RA, that is why you got 4.2.
Oh, okay, sir. Got it, sir.
Sir, it's 0.016, sir.
0.016. sir.
No, sir, got it, sir.
2 decimal tanavale.
Yes, sir, got it.
Okay, so it's 0.16. Okay, I hope everyone is clear. Right? So with this, the magnetic effects of electric current, that is moving charges and magnetism, is done. Okay. So now what I'm going to do is I'm not going to do magnetism and its matter. Rather, I will do a reverse operation of this chapter. So here, what are we doing? With the help of magnetism, with the help of current, we are generating magnetism. The next question is about, with the help of magnetism, can we generate current, which is the reverse process, which is electromagnetic induction. We are going to concentrate on that chapter now. Just give me a minute. I'm opening my slide. So in electromagnetic induction, what is the whole chapter based on? See, if you ask me, this whole chapter is based only on one concept. What is it? You will have magnetic flux. And if you want to induce electromagnetism, what are you supposed to do? If you want to induce electromagnetism, what are you supposed to do?
Changing magnetic flux.
Change the magnetic flux with respect to time and your job is done. Right? So what is magnetic flux? Basically, it is given as BA cos theta or B vector dot A vector. And what is going to be the value of the induced EMF? It will be minus N into d phi by dt. And what is the average induced EMF? It is going to be minus N into phi 2 minus phi 1. Okay, divided by T. And induced current will be equal to magnitude of E divided by. So having this in mind, let's solve the problems. So there is a rectangular loop of area 20 into 30 into 10 power minus 4 meters square placed in a magnetic field of 0.3 Tesla with its plane normal to the field. So the coil has a plane which is normal to the field. Okay, where this is perpendicular. Okay, having said this, what is going to be the angle between the aerial vector and the magnetic field? The first
0,
case.
sir.
The first case.
It will be 0. No, sir.
It will be 0 degrees. So what is going to be the answer? Flux in the first case will be 0.3 into 600 into 10 power minus 4. Or it is going to be 0.3 into 6 into 10 power minus 2. So 1.8 into 10 power minus 2 Weber. Second, inclined at an angle 30 degree to the field. So inclined at an angle 30 degree to the field. When the coil is inclined at an angle 30 degree with the field, what will the aerial vector be inclined to?
60
Then theta
degrees.
will, it will be 90 minus 30, which is going to be 60 degrees. Right? When you take 60 degree, what are you going to get the answer as? Phi 2 will be equal to 0.3 into area is going to be 600 into 10 power minus 4 into cos 60, which is going to be half. So 0.3 into 6 into 10 power minus 2 divided by 2, which is going to be 3. So it will be 0.9 into 10 power minus 2. Third,
Sir,
parallel to the
Zero,
field, theta will be 90.
90.
90. So flux is going to be 0. That's it.
sir,
Tell me.
sir, I'm getting confused when inclined at 30 degree, we should take 90 minus 60, 90 minus 30. When should we take like that?
Listen. So in a question, it's a good question. Everybody listen, okay? In a question, if they mention the coil is, the plane of the coil is inclined to the field, then you should do 90 minus. If they say aerial vector is inclined with respect to the field, then you do nothing.
Okay, sir.
Puriyada? So do this one. A small piece of metal wire is dragged across the gap between the pole pieces of magnet in 0.5 seconds. The magnetic flux between the pole pieces is known to be 8 into 10 power minus 4 Weber. Estimate the EMF induced. EMF is equal to delta phi by delta t. So what is the value of delta phi? 8 into 10 power minus 4 divided by time is going to be half. Answer will be 16 into 10 power minus 4 volt. Or you can write it as 1.6 into 10 power minus 3 volt. Both are same. Clear with this? Listen. Do this one. So whenever they give you the flux as a function of time, what are we supposed to do? When you want to calculate the induced EMF, do minus d phi by dt. Answer.
So 15.6.
15.6, sir. Correct. Which is 15.6. You're talking about the current, no? Current is 15.6, correct.
Yes, sir.
What is going to be the value? 15t square plus 8t plus 2. So what are we supposed to do? T is equal to 2. So 15 into 4, 60 plus 16 plus 2. 60 plus 16, 76 plus 2 is 78. So 78 divided by 5 is going to be the answer. Is it right?
Shouldn't be negative, sir.
No, that is, see, induced current, when you take it, it is going to be positive only. You take only the magnitude, no? Here minus sign does not indicate anything except Lenz's law.
Okay, sir.
So what will be the answer? 78 by 5 is 15.6, no?
Yes, sir.
15.6 ampere. Do this, no? I think there's an NCRT problem. Yeah, it is. A square loop of side 10 centimeter and resistance of 0.7 ohm is placed vertically in the east-west plane. A uniform magnetic field of 0.1 Tesla is set up across the plane in the northeast direction. The magnetic field is decreased to 0 in 0.7 second. It is second space at a steady rate. Determine the magnitudes of induced EMF and current during this time interval. So area is going to be 100 into 10 power minus 4 meter square. Resistance is going to be 0.7 ohm. Okay, magnetic field is going to be 0.1 Tesla. Time is going to be time is going to be 0.7 seconds. Determine the magnitudes of the induced EMF. So EMF will be equal to delta phi divided by delta t, because they have asked magnitude. So how do I calculate delta phi, guys? So what is going to be the angle?
45.
Okay. So theta is 45, correct?
Sir, here in both this case, it's coming out as 45, but we should take like 90 minus 45, right?
Both are same, no? Both are-
No,
It's the
sir.
same.
Here the plane.
Because of the plane, yes.
Yeah, okay.
So the magnetic field is decreased to 0. So delta phi one, initially how much is the magnetic flux? 0.1 into 100 into 10 power minus 4 into cos 45 is going to be 1 divided by root 2 minus final value 0 divided by 0.7. Remember, 1 by root 2 is 0.7. You remember the RMS value? So this and this will get cancelled. So what will you be left out with? 100 into 10 power minus 5, which will give you 10 power minus 3 ampere, which is going to be the induced EMF, and current is 10 power minus 3 divided by 0.
10 power minus 3 volt, no, sir.
Oh, sorry, 10 power minus 3 volt. Resistance is also 0.7. Up it will be root 2 into 10 power minus 3. So wherever you see that 0.7, you can approximate it to 1 by root 2. Up root 2 on the malapoid. So root 2 is 1.414 into 10 power minus 3 ampere. Guys, am I clear? So 0.7 is 1 by root 2 approximately. Because 1 by root 2 is 0.707. You can approximate it to 0.7. So 1.414 into 10 power minus 3 ampere will be the answer. Am I clear? A 10 ohm resistance coil has 1000 turns and at a time 5.5 into 10 power minus 4 Weber of flux passes through it. If the flux falls to 0.5 into 10 power minus 4 Weber in 1 second, find the EMF generated. See, last problem based on EMF. So EMF will be equal to how much? It's going
Del
to
phi
be
by del.
N into del phi by del t, because there are a number of turns.
Yes, sir.
So 1000 into what is going to be the value of del phi? 5 into 10 power minus 4. That is the value decrease, correct? 10 power minus 4. In how much time did it happen? 10 power minus 1 seconds. So it is going to be 5 into 10 power minus 3 divided by 10 power minus 1. 10 power minus 3 to 10 power minus 1.
Sir,
So this will get cancelled. Tell me that.
sir,
Yeah, tell me.
the change is denoted by like flex is decreased by 0.5, but here it seems to be a final value,
That's
like
false 2. Where did they say decreases by? The flux falls 2 means the final value is 0.5 into 10 power minus. Correct only, no? Answer correct, 5 volt.
Sir, we should ignore negative sign, sir, because final value is small.
Which negative sign did I ignore? I ignored nothing.
No, it's final minus initial, no, sir. Del phi.
That is fine, because here I am
Yes.
only finding the magnitude. So again, remember
Yes.
that minus sign signifies only Lenz's law.
Okay.
As long as you don't know what are the directions and all, you need not worry about the minus sign. Okay. Next
Yes.
is the charge flown through the coil in coulombs. So Q is equal to I into T. I is equal to E by R into time. So E is 5 divided by R is going to be, R is 10 into how much is the time it is going to take? 10 power minus 1. So answer will be 5 into 10 power minus 2 coulomb. Got it? So the next concept is based on motional EMF. So the EMF induced in a conductor of length L moving with a velocity V perpendicular to the field is given as B into L into V. So what do you mean by motional EMF? When there is a motion of a conductor taking place in a uniform electric field, then there is an EMF induced. And the value of the EMF induced is going to be equal to B into L into V. Similarly, if there is a rod which is rotating, right, at its one end in perpendicular magnetic field, then the EMF induced across the two ends is given as half into B L square omega, where L is the length of the conductor and omega is going to be the angular speed. Okay. Can we solve this problem? So an aircraft with a wingspan of 40 meter flies with a speed of 1080 kilometer per hour in the eastward direction at a constant altitude in the northern hemisphere, where the vertical component of the Earth's magnetic field is 1.75 to 10 power minus 5 Tesla. So what is going to be the EMF induced? So don't make it too complicated. This is an EMF generated due to the motion of the coil, right? So E will be equal to B into L into V. So B is how much? 1.75 into 10 power minus 5 into length is how much? 40 into speed is how much? 1080 kilometer per hour. So 1080 into 5 by 18 is how much? 300. Huh? So 175 into 3 into 10 power minus 5 into 40. So 175 into 3 into 10 power minus 4 into 4. So calculate this value. You'll get the answer.
Where 0.2.
What is 0.21
One.
now? Okay. Do this fast. A jet plane is traveling west at 450 meters per second. If horizontal component of the Earth's magnetic field at the place is 4 into 10 power minus 4 Tesla and the angle of dip is 30 degree, find the EMF induced between the ends of the wing having a span of 30 meters. So I need the perpendicular component of magnetic field to this, which is going to be vertical. So what is going to be the value of B vertical? B vertical will be equal to B horizontal into tan delta, where delta is going to be the angle of dip. So what is horizontal here? 4 into 10 power minus 4 into tan delta is going to be 1 divided by root 3. Okay. So jet plane is traveling west with the speed. So velocity is equal to 450 meter per second. Find the EMF induced between the ends of the wing having a span of this much value. So EMF will be equal to BL into L into V. So BV is how much? 4 into 10 power minus 3 divided by root 3 into LS 30 into V is 450. So if you calculate this value, that is going to be the required answer. Okay, calculation part, as I told you,
Sir,
I'm giving it to you. Tell me that.
sir, why are we doing BH tan delta? Like, what are we applying
Because,
to it?
see, generally when you calculate the motional EMF, right, you will get that value of BLB only if you take the magnetic field to be perpendicular to the velocity component. So jet plane is traveling west. If the horizontal component of the Earth's magnetic field, that is also in this plane. Okay. The horizontal component of the Earth's magnetic field is in this plane. Then vertical component is the one which will be perpendicular to the motion of the plane. So here, you should not remember that B is only magnetic field, but you should remember B and V are perpendicular to each other. So you should always write the magnetic field component, which is perpendicular to the velocity vector. Purida.
Yes.
Got it?
Sir, so in every problem, angle of dip only will be given, right? So
Angle of dip will be given. Sometimes they'll give you the direct vertical component. Anything can
okay.
be given.
Yes.
See, there are only 3 equations. Since this is the only formula that is available in magnetism and matter. The 5th chapter, had we done problems, we should have done only based on Earth's magnetism. What is the formula? One is tan delta. So tan delta is defined as BV divided by BH. Correct? So if at a particular place there is a magnetic induction existing, the angle made by the magnetic induction with respect to the horizontal is what is called as the angle of dip. Correct?
Okay.
Adhe mari, B is given. For example, angle of dip is not given. They have given you horizontal and vertical. Horizontal and B is given, which go. Then what you need to do is B will be equal to root of BV square plus BH square. So these are the only 2 formulas that are available. And similarly, BV is given as B cos delta and BH is given as B sin delta. Nitish, are you clear?
Yes, sir.
One last problem based on this. No, wait. I just don't want to do this. Conductor falling freely, not necessary. This one. I want you to do this. A metallic rod of length L is rotated at an angular speed of omega normal to the uniform magnetic field. Derive expressions for the EMF induced in the rod, current induced, and the heat dissipation if the resistance of the rod is R. So EMF induced across the rod that we know, how much is that? Half B L square omega. This is actually an NCERT solved example. Okay. So this is how we take the rod. Okay, this one I'll directly explain it from here. Now, if you need to calculate the flux, what is the first thing that we need to do? B multiplied with A. So B is B only. So what is going to be the area swept in one revolution? It is going to be pi L square. So area swept in one revolution is pi L square. Okay. So what is the value of EMF? EMF will be equal to the change in flux divided by the time it takes. So what is going to be the change in flux? B into pi L square divided by the time it takes is going to be capital T. Okay. So this can I write it as B into pi into L square divided by 2 pi divided by omega. Cancel this and this. Answer will be BL square omega divided by 2. That's it. Got it? Okay. So current will EMF will be BL square omega divided by 2. Current will be E divided by R, which will be BL square omega divided by 2R. Okay. Similarly, what is going to be the heat dissipation? Heat dissipation will be equal to I square R into T. So I square is B square L power 4 omega square divided by 4R square into R into T. So R and this will get cancelled and that will give you the answer. Okay. Next. So next set is induced EMF in rotating coil. This is the principle on which the generator works. Okay. So when you talk about the induced EMF in rotating coil, E will be equal to E naught into sine omega t, and E naught is written as NBA omega. That is a maximum induced maximum EMF that is going to exist. That is the amplitude of that EMF, where omega is given as 2 pi into F and maximum induced current is given as E naught divided by R. Okay, based on this, we will do two problems. A circular coil of area 300 into 10 power minus 4 meters square and number of turns to be 25, rotates about its vertical diameter with an angular speed of 40, I'm assuming it is radian per second, in uniform magnetic field of value 0.05 Tesla, obtain the maximum induced voltage. So what is the value of E naught? It is NBA omega. So N is 25 into B is going to be 0.05 into A is 300 into 10 power minus 4 into omega is going to be 40. Multiply everything, that will give you the answer. The answer will be 1.5 volt. Okay, can try it later. I hope the concept is clear, right? Next. So I'll do one last problem. Then don't leave. I have something to discuss. A flat coil of 500 turns, each of area 5 into 10 power minus 3 meters square, rotates in uniform magnetic field of 0.14 Tesla at an angular speed of 150 radians per second. The coil has a resistance of 5 ohm. The induced EMF is applied to an external resistance of 10 ohm. Calculate the peak current through the resistance. So E naught will be equal to again NBA omega. N is 500 into B is going to be 0.14 into A is going to be 5 into 10 power minus 3 into omega is going to be 150. So they're asking the peak current. So once you calculate E naught, peak current will be equal to E naught divided by R. So this value divided by R is going to be 10. calculated, that will give you the answer. And the answers are oh, sorry. The coil has a resistance of 5 ohm and there is an external resistance of 10 ohm. So what is going to be the total resistance? R will be 15 ohm. So calculate the value of E naught and divide it with 15. That will give you the required answer. Okay. So is it clear?
Sir, we are adding resistance because we are assuming it to be in series, sir.
Yes, not assuming. The coil itself has a resistance, right?
Yes.
And the induced EMF is applied across the external resistance. So they are like together, no? Okay, if you want to take it like series, yeah, it is the same thing because the same amount of current is flowing through them.
Yes. Okay, sir.
It's series, yeah. You can take it in that way. Okay. So, yeah, as I mentioned, no, since see, as per the next test, you have 4 chapters. What are they? Moving charges and magnetism, magnetism and its matter, electromagnetic induction, and alternating current. See, this alternating current is one chapter which I wanted to explain. Okay. Since I don't have time, we don't have time, right? Because it's already packed this week. So what I'll do is part test 2. Listen to this carefully. Part test 2 will be postponed to the next Monday, not the coming Monday. It will be postponed to the subsequent Monday. Is that point clear? So I'll
Yes,
push
sir.
it there. Accordingly, part test 3 will take a hit. Okay. Because that schedule will get disturbed. This is done only for physics. Okay. Other 2 subjects I'm not going to disturb. It is going to go only for physics. So for physics, part test 2, I'm going to push it to what is upcoming Monday's date? Date another actually 4th, 5th, 5th you will not have the exam, you will have it on 12th. Purida. You will have it on 12th, and accordingly, based on how the subsequent chapters for part test 3 are being completed, part test 3 will be held. I'll inform at that point of time. Is that clear? So Monday there is no test for part test 2. Is it clear? Because I want to teach alternating current. That is one of the toughest chapters. Yeah. So that's it from my side. Any other doubts?
The part 2 test will be held on 12th or so.
12th.
Physics.
12th. Physics
Part 3,
alone.
sir.
3, அதுக்கு தகுந்த மாதிரி it get postponed. That depends because I'm taking out 2 days no from there. See, when it goes to 12th, 5th, 6th, 7th, I was actually supposed to teach some. You will have part test 2 இருந்திருக்கணும். Yeah. So part test 3, I'll inform at that point of time, depending on how I'm able to complete the chapters for part test 3. After that, everything will fall in sequence. And the final full portions test, that will fall in sequence. So only adjustment will happen for test 2 and test 3. Because last time also I couldn't teach current electricity because we focus more on capacitors, no. But this time I don't want to miss it. That is the reason I'm postponing. Okay.
Okay.
Yeah. Okay, that's it from my side. We'll wind up.
Thank you, sir.
Yeah.
Sir,
Tell me now.
sir,
Yeah,
this is regarding schools, sir.
1 minute.